The model we use is a water flow model from the United States Geological Survey, or USGS. We use real data from the Milwaukee River to understand how the river's water changes every day. This kind of model is used in environmental engineering to study rivers, predict floods, and manage water resources. Also, the model is based on something called a time series. That means it looks at water flow data over time, day by day, and shows how it increased and decreased the water. The main data we used were the date and the average daily flow of the river. We made graphs using this data to show how the flow changes during the year. For example, we saw that the river has less flow in summer and more in fall. We also add the trend line to help us see if the flow is going down or up over time. Also, this line helps us understand long-term changes that are not easy to see just by looking at the numbers. The model is important because it helps us answer questions like, is there enough water for people in nature? Are there risks of floods? Can we plan better with all this information? And yeah. By studying the Milwaukee River, we learned how rivers behave and how we can use this knowledge to protect the environment and use water wisely. And now Andrea will show you the code in R.
To replicate the model, we followed a YouTube tutorial called USGS Daily Data to R Time Series Plot Tutorial from the channel Clear Water Clarity. The video showed how to download river flow data from the USGS website and how to visualize that using the R programming language. First, we visit the USGS NY and WBIS website and selected a station that measures the flow of the Milwaukee River. We choose daily data from the 1st of January of 2024 to 1st of January of 2025. And we downloaded the file in TXT format and imported it into R. We can observe here that we have a lot of information. So we clicked it here and we selected the discharge screen and we selected the date here. So then we went to R and we installed and loaded necessary R packages like the tidyverse, data retrieval, and lubricate. These packages help us read the data, clean it, and make graphs of them. We organize the data into columns, the date, flow values, and other necessary variables. Next, we used ggplot 2 to create a scatter plot of the river flow over time. We added a red dashed trend line. It's this one. Let me show it to you. This one, so we can observe the trend line here. Using the GM smooth method equals LM. This one, that is the equation and the function that we use. I'm going to explain it later. To understand how the flow changed through the year, we also explored other visualizations like box plots by month and bar plots to better understand the patterns of the data. Some small challenges appeared during the process, like correcting the date formats and installing some libraries, but we solved them with help from online documentation and help from R. In the end, we were able to fully replicate and even improve the original model by adding these thread lines, because in the tutorial it was only the basic scatter plot, this one. So we needed to add all of the trend lines and detailed visual features. The input data. For this model, we used, as explained before, the real-time water flow from the USGS National Water System. We used the data from this selected site number, the Milwaukee River. And this is the dates that we, as I explained before, the start date and the end date of the data. We choose this because it's free and accessible, it's accurate and collected by experts, and it's directly related to water quality and flow, which is relevant to environmental engineering. And the equations that we used, as I explained before, is a very simple one from the linear regression, that it's y equals a plus bx, where y is a predicted river flow in CFS, which is cubic feet per second, X is the time, A is the intercept, which is the starting point of the trend, and B is the slope, which is the rate of increase or decrease in the trend line. So as I explained before, we used this function, which creates a model for the best fitting straight line through the data points. And then we plot it to draw the trend line in a graph, which visually shows the same trend from the equation. It's a very simple equation, but it helped us in this so we can observe the decrease or increase of flow through the months or through the years.
Hi, my name is Jimena and I'll be presenting the results and interpretation of our model. After replicating the flow model of the Milwaukee River using R, we generated several visualizations to better understand the data from January 24 to January 2025. First, we created a box plot to show monthly flow distribution. One of the key things we notice is that the flow tends to peak between March and May, especially in April, which shows a lot of variability, probably due to seasonal snowmelt or rainfall. On the other hand, during the months like July and August, flow values dropped significantly. Then we plotted the daily average flow. Here we saw that while there were days with really high values, especially around late March and April, the overall trend decreased over the year. And this became clearer when we added a linear regression line, which confirmed a general downward trend. To better understand patterns better, we used Loess smoothing, and this helped us visualize that flow starts high early in the year, dips mid-year, and rises again towards December. And even though we didn't compare it directly to an original published model, our results make sense considering seasonal hydrological behavior, and the interpretation here is that the river flow is strongly influenced by climate and seasonal events, which highlights the importance of monitoring and modeling water data for better resource management.